Okay, so hi everyone. So for those of you who don't know me, my name is Ilyas, and I think some of you have been here before, definitely. And so the purpose of these live sessions is really just to give you a space to ask me any questions that you have when it comes to mathematics. Um, it can either be specific questions, or it can be concepts that you would like me to further explain. Um, just for the purpose of completeness, we've got these concept videos, and I'm pretty sure you probably know how to watch them. All you do is that you just choose the topic that you want to learn, like trigonometry, and you just click on this globe icon, and then it takes you to the video. And you've got concept videos from grade 8 to grade 12, and you see this is like a section mind map that you can basically, let's say you're struggling with functions, you could go back to grade 8, 9, 10, 11, and 12 and rebuild that foundation if you feel that it's not as strong as you want it to be. So that's the nice thing, is that we haven't just organized it by grade, we've organized it by section. So like trigonometry, you guys are doing this now, double angles, but maybe you're struggling to understand what is a trig ratio in general. So you could learn reciprocal ratios, you could learn, just normal things that would have been covered in grade 10, but maybe as you're just not 100% with those things. Okay. That's the first thing. The other thing that Tutonic gives you is that we give you access to the bank. And the bank is basically all the questions that Tutonic has received over the last couple of years. And this is nice because you get to work through different types of questions. So if you say, okay, I'm busy with compound and double angles, I want to look at some of the questions Tutonic has received. So in fact, Naima asked this question. Do you see that? Naima asked this question yesterday or 2 days ago, right? This question 5.4. But then luckily we actually made a video on that question like 3 years ago, 2 years ago. So that's the nice thing, is that you can actually look at all the questions that we've received and you can actually practice them, and then you've got the video on the next slide. Do you guys see that? Nafisa, Tess?
Yes, we do. I
Yeah,
actually did some of them, and it's helpful. It's very helpful.
So you've asked a
Okay.
very, very
So that's the two aspects. You can either learn concepts or you can look at past questions that Tutonic has received. And then, of course, the third thing you can do is you can actually ask us any question. And that's sort of really dynamic. So, the tutor might even make a new thing for you, or they might point you in the particular direction. And of course, the fourth thing is the live session. So maybe we can start, if you guys have any questions, if there's any concept that you would like me to explain, because I see there aren't any questions right now. So otherwise, if there aren't any questions, then I'll ask you questions.
Ilyas, do you have a concept video on how to sketch the cubic graph using the calculator?
How to sketch the cubic graph using the calculator. Let's see, it should be. It's under calculus. I think it might be this video. But in the last, I don't know if you remember, in the last live session, we actually spoke about it. Do you remember it in the last session at the end?
I don't remember.
Because I will find it and then I'll send it to you. Because I mean, if it's not there, then I'll make a new concept video like last week. I mean, you should know how to,
Okay.
So we can do it now if you want a revision on that.
Okay, sure. Yeah.
Okay. So you want to give me an equation? A cubic equation.
Oh. Let me look for.
Akhlaq, how are you? Okay. So how many, what can you guys tell me about the cubic graph in the meanwhile? Anything that comes to mind? Nafisa, Tess, Severia, what can you tell me about the cubic graph?
There's three x-intercepts, and then there's a stationary point, and then there's a point of inflection. Yeah, that's all.
So you mentioned x-intercepts, you mentioned turning points, and you mentioned inflection. Okay. And you mentioned that there are 3 x-intercepts, right? Are there always 3 x-intercepts?
No, not always.
Not always, right? Because you
But
could have a graph.
mostly.
You could have a
Yeah.
graph like, maybe like that. So it's still a cubic graph, but it doesn't. That's one x-intercept. Or you can have a graph that does this. So it touches here and it touches here. All right. Do you remember what we said this
I
was?
see the vision on
Yes.
Telegram.
Do you guys remember what we said this was? When it touches and it comes off again. We gave it a name.
The bouncing point. The bouncing point.
Yeah, it's a bounce point. So it's sort of like like a ball, just bounces off. Yeah, like this is like a floor, and then it bounces off like that. So yeah, so cubic graphs. I think the most accurate statement is that they have a maximum 3 x-intercepts, and they must have at least one. Okay, they must have at least one and maximum 3. And it's all got to do with how the graph is shifted up and down. Every cubic graph has at least one stationary point, which is when the gradient is naught. And by the way, guys, you must just tell me if I must repeat anything. You can just tell me if there's anything you want me to repeat. And then the inflection is when the concavity changes. So let's do the question that Amaro asked. Naima, sorry. Let's copy. Okay, so it says given x cubed minus x squared. Okay, you can just erase that actually. X cubed minus x squared plus 1. Okay, now they're just asking you to find the y-intercept. Okay, so how do we find the y-intercept? You guys can answer, you can just answer. How do we find the y-intercept?
Make x equal to 0.
Make
Or
x 0.
it's just 1 because that's the
Yeah. Guys, I'll get that. Tess, Severia. Okay. So y equals 1. That's the y-intercept, okay? And the x-intercept, you make y0. Now, we made a concept video last week, Nafisa will remember, where we spoke about how to solve a cubic equation. Do you still remember the rule, Nafisa?
The one that you do, or which one? My one or the the synthetic one? Yes.
Yeah. So you're gonna tell me what I must do.
You first find the factor that gives you 0.
Yeah. So just a reminder, I know some of you haven't done calculus yet. So there's concept videos on calculus that I want you guys to all watch. If you haven't, because then that will make this section a lot it'll be a lot easier to understand. Okay, so the first thing you find her, Nafisa,
You find a factor.
a factor or a root, yeah? Factor. What's the difference between a factor and a root?
Isn't the root where the graph touches the axis and then the factor will give you 0? I don't know. Isn't it?
So if the root is 1, what's the factor?
1 and 0.
No, x minus 1.
X minus 1.
If the root is minus 2, what's the factor?
X plus 2.
Okay. If the root is x minus 7, then what's the factor?
X plus 7.
Yeah. Okay. So that's the difference, right? So the root is actually the number you sub in, but the factor is the bracket that if you sub that in will give you 0. Okay. Because if you sub in 1, what do you get? 0. If you sub in minus 2, you get 0. If you sub in minus 7, you get 0. Okay. So which factor works, or which root works?
1 works.
1 works, right? Because 1 minus 1, which is 0, minus 1, which is minus 1, plus 1, which is 0. So if 1 is a root, then what's the first factor?
-1.
No, the factor. If the root is 1, then what's the factor?
X minus 1.
X minus 1. Nice. But so you're going to do your synthetic division way. So what is the rule again?
You write down the 1 on the left hand side and then you write the coefficient of each x thingy. Yeah.
What's the coefficient?
So it's 1 and then -1 and then -1 and then 1 again.
So all she's doing, she's writing the coefficient of these terms. Okay, so it's 1, minus 1, minus 1, and 1. Okay, right, next. Afisa, what do you do next?
Then you just bring the first 1 right down and then you multiply that with the 1 on the left hand
Bring
side.
the 1 down here, right? So
Yes,
okay.
and then you multiply that with the factor, which is 1.
Multiply
and then you
this
write
with that.
Yes, and then you write plus 1 by the second coefficient, below the second coefficient. Yeah, and then you add those two, which will give you 0. And then you say 0 times 1, which is also 0. Then you write that 0 under the third coefficient. And that will give you -1. And then you multiply that with the +1 on the left. And then that will give you +1, -1. And then you write that. And then gives you 0.
So basically, whatever's here, you're adding this to give you that. Adding this to give you that. Okay, so what's the answer?
So in the first bracket, you say x minus 1. Okay, you have it there. And then it's just x squared minus x. Isn't it? Minus x.
Mm.
Yeah,
No,
that's
actually, x squared minus 1.
Why -1?
Because this is the coefficient of...
Oh, the third one. Oh,
Yeah, because this is always going to be 0. Right? Okay. So this is the x squared, this is the x term, and this is the constant. So it's x squared minus 1. Okay. Can we break that down? Can we make it easier for ourselves?
Yeah, please.
No, I mean, can we simplify this? Okay, can we simplify this?
Yeah, you can. The second bracket is, can you? Yeah, you can.
Yeah, you can.
How? How are we going to
Do you
make it simple?
multiply the
Isn't it difference of two squares? Can we do
Yes.
that? Okay.
So then it's
So
x
it's-
minus 1.
And then x minus 1 and then x plus 1 in the two brackets.
Great. Do you guys see that? Makes sense, guys? Girls? Keep on
Yes.
saying guys. That's the thing. Like, my math teacher used to make that mistake. Because he used to teach, like, at a girls' school, and he always used to call them. So you got into the habit of calling them girls. Like, hey, girls. And then you came to my school, and then you used to call me girls. To all the guys. You got into the habit. Anyway, I hope you don't mind. It's just a habit. Okay, so the equation of the graph is y equals that. Okay, in factorized form. So what's the x-intercepts? Amara, what's the x-intercept?
So x is equal to 1 and negative 1, sorry.
And what can you tell me about this, the x minus 1 squared? What
It's
did we say?
it's also the bounce point. isn't it?
Right, great. Okay, so if we say that whenever there's a factor that is
Oh.
squared, then that, because this is 1 twice, right? It's twice. It's 1 twice. It's x minus
Yeah.
1, x minus 1. And whenever there's two factors which are the same, it gives you a bounce point. So we know that there's only going to be 2 x-intercepts, which makes sense. So you asking, how do we plot this, right?
Yeah.
Naima? So the first thing I would do is I would work out the intercepts. So this is my step. So we start the concept video now. Okay, so we're going to start off by looking at the y-intercept, okay, and the x-intercepts. Okay. And what are the x and y-intercepts? The y-intercept is going to be at 1, okay, because we made x naught. And we just found out that the x-intercept is going to be at -1 naught and +1 naught. But we also said that at 1, we're going to have a bounce point. Okay, but that's fine. Okay. The next thing I'm going to do is I'm going to work out the shape of the graph. And to do that, I'm going to use the gradients. Okay, I'm going to draw a number line. Do you guys remember the number line?
Yes.
Okay, I'm just going to draw the number line. And on this number line, I'm going to plot the turning points. So we have to find the turning points. So how do we find the turning points of a function?
Minus b
Stationary
over
points?
2. Oh, sorry. The derivative will make it equal to 0.
When will we use minus b over 2a?
It's for the parabola only.
Correct. Okay, good. Okay. Did you guys watch that concept video on the parabola? Like I asked you to watch?
Yes, we did. I did.
Okay, so what's the domain of the parabola?
X is an element of real numbers.
Correct. Okay. And what is the range of the parabola? Depends, right? If the parabola was like that, what's the range? Guys, no. Yeah, can you hear me? Yeah, you can hear me. What's the range?
y is greater than the y value of the turning point. I think.
Correct. And if the graph is like this,
Also, y must be
It's less than the
Must-
y value of the turning point.
correct. It must be less than with the y value of the turning point. So do you see, it's not always greater or lower. It depends on the graph. But you know, if you'll know if this is a smiling, if you look at the x squared, right? If it's positive or negative. This is
Yeah.
negative x squared, right? Okay. So good. I'm glad that you watched the concept video and watch all the others also, please. Okay. So okay, what are the Amara, you said how do we find the stationary point?
So we find the derivative and we make it equal to 0. So this one would be 3x squared minus 2x minus 1 equal to 0.
Okay. And then
And then
okay,
we
we
find, yeah, we can factorize that.
so what are my brackets going to be? Do you see this is a prime number, right? 3. It's a prime number.
Yeah.
So because it's a prime number, we know there has to be a 3x because it can't be divisible into anything else. And there must be an x there. Okay.
So -1 and
Where's the -1 going to be? Actually, it can only be in one place. So this is going to be 1 and 1. So where's it going to be plus x plus 1 or x minus 1?
I think minus.
X minus 1, right? And x plus 1.
Mm-hmm.
So what are my turning points going to be? What's on the number line? What are my turning points going to be?
Well, isn't it positive 1?
Positive 1 and
Negative 1/3.
negative 1/3. Great. So these are my stationary points. Do you guys agree? -3, 1/3, and 1. These are the points where my gradient is 0. Okay, do you guys see that? It's where the gradient is 0. Now I want to know what is the shape of my graph. So what I do is I sub in different values for the gradient graph. So I'll choose an x value to the left, an x value between, and an x value to the right. Do you guys see that? Because if I sub in an x value into this equation, what is it going to tell me? It's going to tell me the gradient, right? Isn't this the gradient, the derivative? Guys?
Yeah.
Amara, Nafisa? Isn't this
Yeah,
the gradient? Okay.
I see.
So if you sub in the value of x to the left of -1/3, what is it going to be? Positive or negative?
A negative. Isn't it?
Negative or positive? Negative. Do you say negative or positive?
Negative.
Want to be positive?
Why?
If you sub in a negative value less than -3, so like you sub in -2 squared -2 times -2 -1, it's a positive answer. If you sub in the value less than -1/3, what did you sub in? Nafisa?
Huh? Oh, I was just guessing. Want to give you a negative answer? No. No.
Why would it be? You mustn't guess. You mustn't guess.
Sorry.
Because this number line is a graph of the derivative. It's the derivative graph, because we want to know what is happening to our gradient. Because if we know what's happening to the gradient, we can say what's happening to the shape. So if you sub in -2, what do you get? What do you get? On the calculators, guys.
15.
You get 15, right? And 15 is positive.
Yeah.
And if you sub in between these, so if you sub in 0, you get? You get a negative, right?
Yes.
You get -1.
Right. And after 1?
You get a positive.
It's a positive.
Positive. So what's the shape of my graph then?
So it starts from like it down and then it goes up. So like it'll be. Yeah.
Wait. Say it again.
So it starts like from down and then it goes like concave up and then it goes down again and then it goes up again.
Like don't it's concave. Remember, concave is a second derivative, eh? So it's positive, right? So it's going up like this.
Yeah, and then it'll go down and then it'll go up again.
Right. So that's, do you guys agree that's the shape of the graph?
Yes.
Okay. So we know the shape of the graph and we know the x-intercepts. No, don't do that. We know the x-intercepts and we know the y-intercept. So do you agree we can plot it now?
Yeah.
Yes.
Yes.
So we draw a Cartesian plane. Okay. Where are my x-intercepts?
-1 and 1.
Okay. Right. Good. And my y-intercept?
0 and 1.
0 and 1.
1.
So like there, right? And what did we say about 1?
It's a bounce point.
It's a
Also
bounce
turning.
point. But isn't the bounce point a turning point?
Yes.
Remember, guys, remember we said the bounce point is a turning point. So does it
Yes.
make sense now? Do you see? You got 1 to be the turning point and 1 is the x-intercept. Do you guys see that? 1 is the
Yes.
x-intercept and 1 is the turning point. So that means it's a bounce point. So we've just proven it, basically. We've just proven it. Hi, Shaida. See, okay. So how are we going to plot this? So we know this is a bounce point, so it's going to come up like this, right? And then it's going to, so, but sorry. Let's first do the let's do the, we did the x-intercepts, you must do the turning points. Where are the turning points? It's got to be here, and where else? At a 1, and where else? Where else is the turning point? Guys, where's else is the turning point?
-1/3.
Over 3.
And that's kind of like over here, right? Like over here. Okay. So that's our turning point. And we know our turning points, we know the shape of the graph. So it'll probably look like this. So it comes down, cuts the x-intercept, but it's a bounce point. So then it comes back up like that, goes through the y-intercept, and then look there, we're at -1/3. So what must we do? We must turn. Are we happy? Doesn't
Yeah.
that look like this? You see the shape? Positive, negative, positive. Positive, negative, positive. Positive, negative, positive. Positive, negative, positive. Do you guys see that?
Yeah.
Trying to do another example? Another graph? Just to solidify the concept.
Okay.
Or do you want to move on? Are you happy with this?
Do
Yeah.
another one, please.
Okay.
Okay.
So you might just find one. Yeah. So step one, we said the intercepts. Intercepts. Right. Step two, turning points. Step three is the shape. And by the shape, I mean the number line. And once you have those three things, you can plot any cubic graph. Any cubic graph. Any cubic graph. Like any cubic graph.
Are there other ways to find the x-intercept? Because I don't like this synthetic division.
Yeah, you know, I also don't like. So, but Nafisa likes this method.
I love it. Okay,
Um,
fine. Do the other one because they like
so-
it. It's just me that
so-
prefers this.
So,
How do you even understand it, Nafisa? Oh, gosh.
It's so much.
So-
I can't factorize the other way. That's why it takes super long. That's why I
Yeah.
like this one.
so there's two.
But Shem, do the other one for them.
There's,
It's okay.
there's two ways, and I prefer the first way. But there is a concept video on it, so I'll show it to you. But there is a concept video as well. So let's take the graph: x cubed minus x squared minus x plus 1, right? And we know that one works for this equation. Do you guys agree? If you sub in 1, it works, right? Do you see that? If you sub in 1, it works.
Yeah.
Right? So therefore, that means that x minus 1 is a factor. Do you guys agree?
Yeah.
Because if you sub in 1, then this bracket becomes 0. Okay. So now I create my second bracket, because all I'm trying to do is I'm trying to recreate this, but in factorized form. So I'm going to ask myself, whatever I write here has to multiply by this x to give me x cubed. Do you agree? Whatever I
Yes.
write here. So what must I write there?
X squared.
Right. X squared, because that gives me x cubed. But if I write x squared here, that x squared is going to multiply by this x, but it's also going to multiply by this, right?
Yeah.
So we have to be careful. But luckily, x squared minus x minus 1 is also just x minus x squared, right? So you actually have both of these terms already sorted. In other examples, you won't, but that's the concept video. But now we need minus x, right? Do you see that? We need minus x. So how can I get, what must I write here to give me minus x? If this is going to multiply by that. Naima, what must I write here that multiplies by this to give me minus x?
Minus 1.
Minus 1. And then you're done. Because the minus 1 times minus 1 is plus 1. So I prefer that way, but both ways work. Okay, so you see this is the same. Okay, so let's do another example. And I'll use both ways to find the x-intercept so you guys can practice. Okay, so let's get another example. You seen it on the group. Amara. Okay. Is that the other one, Naima? Oh, wait. Do you want me to finish the question? Or do you want me to do
Oh
another?
no, it's fine. No,
sure?
it's fine.
Are you sure?
Yes,
Okay.
yeah.
Amara, your question has been answered on a bank. I'll send it to the group afterwards. It's been answered before. Amara? Amara?
I don't think she's there. I think she went to the kitchen. She's coming back now.
This isn't the first time. Okay. Okay. Anyway, we've answered it. So do you have another cubic equation that we can plot? It's, yeah. Almost we create one. Do you guys have another cubic equation? Isn't there one in your textbook? Do you have a textbook with you?
Must I send one?
So,
If you have
yeah,
one,
you can send me.
or just
Okay,
tell me and I'll
fine.
write it down. You know, just
I'll
don't need to send
find
one.
a difficult one for you.
Yes, good. Okay.
So the method you showed me, will it work for like all the cubic equations?
All of them.
Find the x-intercept.
All of them, yeah.
Okay.
Remember, when you're solving for naught, you can always divide out. So like if you had 2x squared plus 2x cubed plus 4x squared plus 6x plus 4 equals naught, you can always divide out by the -2, right? So it becomes x cubed minus 2x squared minus 3x minus 2 equals naught. So you can always simplify it. Do you see? That's the nice thing when you're making something equal naught. Okay, you get one. Afisa?
Yes, I did. I'm gonna send it now. 2 seconds.
Maybe what we should do is for these live sessions is like annotate, or like, you know, on like YouTube videos where they say like what you did at question at like timestamps, you know? You guys know what I mean?
Yeah.
Like on YouTube videos, like if it's like a long YouTube video, then you say like at 32 minutes, they did this. I think we're gonna do that actually. Okay, which one? But now give me the graph. I want to sketch a graph.
Oh, I thought we
Oh, we can do both. But I mean, let's first master sketching.
Okay,
Then
I
Okay, I have a
got one.
question. So
Do you
what
have
if
one?
there's not always 4 terms? Like, you know, in the equation.
Give me example. Give me example. I'll show you it works all the time. It always
Okay,
works.
x cubed
Do you have an example? Y equals?
x cubed minus
Yeah.
2x
Yeah. 2x, yeah. So there's no x squared
minus
term.
2
Minus 3.
minus 2.
Minus 2. And what's the first root?
What?
What's the first? I can find it now. Because remember, the first step is to find one answer first.
Oh, okay.
Minus 2. Oh no, this is not. This doesn't give you any real answers. But we can actually change it. Let's see if we can change it. 8 minus 4. Yeah, if we make this -4, it will work. Okay, if we make this -4, then 2 works, right? The root 2. If the root is 2, then it works. Because what is it? It's 8 minus 4 minus 4, which is 0. Okay, so what does that mean? What's the first factor? If 2 is the root.
Minus 2.
Not -2. X minus 2.
Yes, x minus 2.
X minus 2, right? Okay. So what must you multiply x by to give you x cubed?
X squared.
Right, x squared. I'm glad we're doing this example. But then what happens when we multiply this minus 2x? What do we get? What does this give us? Naima? We've got the x cubed sorted, but
yes.
what happens when we multiply the x squared by the 2? Because it multiplies by both, right? So what do we get?
2 negative 2x. Wouldn't.
Yeah, right. So do you see there's a problem here? Because there's no x squared. So
Yeah.
the way you deal with that is that you add 2x squared. So then you write here plus 2x. Because what does that do? If you write 2x here, then this gives you times x gives you positive 2x squared, which cancels out the 2x squared. Do you see that?
Oh, okay, yeah.
And then what happens here? Minus 2 times minus 2 times 2x gives you what does it give you? Minus 2 times 2x.
Minus 4.
X, right? And what do you need?
Yeah. You need just negative 4.
No, you need minus 2x. We haven't done the x's yet.
All right.
So you need minus 2x. How do you go from minus 4 to minus 2?
You minus.
They don't minus, you from minus 4 to minus 2. Minus 4, minus 2. How do you go from minus 4 to minus 2?
You add 2.
You add 2.
Isn't?
Because this 2 will multiply by the x to give you 2x. Do you see that?
Yeah. Yes.
So it's 2x minus 4x, which is minus 2x. And then 2 times minus 2 is minus 4. Do you see?
Yeah.
Okay. But I think maybe let's try the synthetic division way. So the synthetic division way would say...
So much easier. Literally so much easier.
Okay. Hold on. 1, 0, minus 2, minus 4. Why the 0? Because there's no x squared. You mustn't just ignore it, okay? So, and then you draw another line, and then you bring it down 1. So then you say 2 times 1, which is 2. What's 0 plus 2?
2, and then you times the 2, but that will give a negative, I mean positive 2, positive 4, sorry, and then yeah,
Minus 2 plus 4
is 2, and then that 2 times the other 2 will give you positive 4, and then it cancels, which is 0.
And therefore it's x squared plus 2x plus 2. So in this example, it's easier, but the others, it's yeah. So in the concept video, Naima, I've actually shown you both methods.
Okay.
So if you go through it and both methods, if you know both methods, then it's fine, you know. So if you're struggling with the one, you can try the other one. Okay. But we're sketching graphs now. Which graph must I sketch here?
I sent a few questions. You can choose which one is more difficult. Then you do that one.
Oh, okay. All right. Okay. Just erase that. Okay, let's try x cubed minus 2x squared. So I want you guys to all do this with me on your pages, okay? x cubed minus 2x squared minus 7x plus minus 4. So what's the first step to sketch the graph? You find the
x-intercept.
or all the intercepts, right? X and y. So start with the y because it's easier. So what's it going to be? What's the y-intercept, guys?
0, -4.
-4, right? So over here. Okay, and now the x-intercepts, right? Okay. What's the factor?
-1.
-1. So what's the factor? That's the root. What's the factor?
X
Oh, 1.
minus, I mean, X plus
X
1.
plus 1.
So then you say x squared to give you the x cubed plus x squared, but you want -2. So you say minus 3x, but you want -7. So it becomes -4. But then we do synthetic division. So we got -1. 1 minus 2 minus 7 minus 4. Okay. We bring that down. So then we say -1 times that. So it's -1. -2 plus -1 is?
-3, and then -3 times -1 is +3, and then 7 -7 plus 3 is -4, and then that times the -1 is +4, which is equal to 0.
So if you get x squared minus 3x minus 4. Okay, so both methods give you the same answer. Does it make sense?
Yeah.
Okay, the concept video on this one is, you just go through that. Okay. So let's sketch. So I don't know why did I do that? Okay. So can we factorize x squared minus 3x minus 4? Can we factorize that?
Yeah.
To what? Who wants to do it for me? Who's gonna do it for me?
I'm doing it.
Oh, okay.
X minus 4 and
X minus 4 and?
X plus 1.
Correct. Okay. So do we have any bounce points?
No. No, we do. Oh, we don't.
Yes or no? I want consensus.
Okay, I think we do.
We do, because there's
Think,
two.
don't think.
Factors.
What's the reason why we have? Do we have? Okay,
Because
yes or no, and then justify, just like in English.
yes, we
Explain
do.
why. Okay, yeah. Why do we?
Because these two x-intercepts where it's equal to -1, because the factor was -1, and then we worked out from the quadratic function that x is also equal to -1. That's why.
So we've got a -1 there, and we've got what else? We've got a +4. So maybe like over there. 4. So we've got our x-intercept, and we know that -1 is a bounce point. So I'm just going to make that a nice red. Okay. So that's the first step. Then what's the next thing? What do we find next? What's number 2? And how do we find the turning point?
Find the derivative and make it equal to 0.
Okay. And what's the derivative? So derivative
3x squared minus 2x minus 7.
3x squared minus 2x, 4x,
Yeah, 4x
4x minus 7, and that must equal,
equal to 0.
right. Okay. So how are we going to factorize this? What is definitely a factor? Let me ask you that. Without even having to work it out, what is definitely a factor?
Isn't the 3 we're going to definitely put it down because it's a prime number? Something like that.
Yes, but do you agree that x plus 1 is definitely a factor? Because isn't minus 1 a bounce point?
Oh, yes. Oh, yes,
You
your
guys,
bounce point is your turning point.
the bounce point is a turning point. So you already know that this is going to be, so every time you have a bounce point, you already know that that factor is going to be in your derivative, equals naught. Okay? And in fact, if you choose to study maths further, you will, they'll explain to you why that's the case. Okay? But x plus 1 is definitely a factor. Then what else is going to be the factor?
7, negative 7 over
My-
3.
Huh?
Yeah.
Factor,
Sorry,
not root.
sorry. X minus 7 over 3.
Or just 3x minus 7.
Oh, that.
Because you are right, but just, you know, you've already simplified this. Yeah. Okay. So what is x equal to? What are the x-intercepts? I mean, the turning points?
Negative 1 and 7 over 3.
What's 7 over 3 roughly?
2 comma 3.
So like here, maybe. Okay. No, like the yeah. Okay. So then what's next? We found the turning points.
Now the shape.
And how do we do the shape?
The
What do we draw?
The number line isn't. Oh, I don't know.
Yeah, the number line, right? So the number, and what do we put on the number line?
The turning points.
Okay, which are?
Negative 1 and 7 over 3.
Right. And what is this number line representation of? What is it going to tell me? Yeah, shape, but in maths terms.
What?
What's
Sorry,
what is the shape representation? Like, what's the maths version of shape? Like, what word do we use to describe shape in maths? It's derivative, right? Shape. It's gradient.
Oh, yeah.
So that's why you're not going to sub into the function, right? Because that's going to tell you the y.
Oh,
You
yeah.
don't want to,
Yeah.
you want to work out the shape, so you're going to sub it in. Yeah.
The derivative.
Okay. So what is, so when you sub in less than minus 1, it's going to be?
It's going to be so it goes down, like it's going up. I mean,
So before we do that, less than minus 1, is it positive or negative?
Positive.
positive.
All right. And then between, if you sub in like naught,
Negative.
and then,
Positive.
right. So how's the graph going to look? I'll give you 10 seconds to draw the shape. And then we'll see. Have you drawn it? Okay, some 10 seconds. Just tell me you've drawn it.
Yes.
Have you all drawn it?
Yeah.
Okay. Did you get something like this?
Yes.
Yeah.
Because it's positive, negative, positive, right? Just to make it easier for yourselves, well, not really make it easier, just to blow, make it like more interesting. What is the graph of 3x squared minus 4x minus 7? What is the graph of? Like what type of graph? What type of graph?
Parabola.
Sorry, what did you ask?
The parabola.
The graph of 3x squared minus 4x minus 7.
Oh yeah, it's a parabola.
What type of parabola?
A frowning parabola.
Frowning.
No, no, it's
Sorry,
a
smiling.
smiley.
So it's going to be like that, right? And what are the x-intercepts of this frowning parabola?
-1 and 7/3.
Do you agree? The x-intercepts of the derivative is the same as the turning points of the function.
Yes.
So it's -1, 7/3. So here on my x-intercepts, so if I just draw a line like that, do you see this is a graph of the derivative, right? To the left of my turning of my x-intercept, what do you know about the graph? What can you see? It's positive. Then between the turning points, it's negative. And then
Positive.
right. Do you see that here? Positive, negative, positive, positive, negative, positive. Are we happy?
Yep.
Yeah.
So why I'm telling you that is that before you sub in, you can actually predict what it's going to be. Because if you know how this graph looks, you know it starts off positive, then it goes negative, then it goes positive. You don't have to sub in. Do you see?
Yeah.
If this was a negative parabola, frowning parabola, right? Like that, then it would be negative, positive, negative.
Yes. It would be the other way around.
You see, here you've got positive, negative, positive. So just because I knew this is positive, I knew it's going to be positive, negative, positive.
Yes.
So that's just a quick way to do it. Do you guys see?
Yes.
So there's always tricks that you learn. Okay. But let's go back to this. So we know the shape. So let's plot. We can plot now. So we know it's coming up like this. We know this is the bounce point, right? The x-intercept. So we know it's going to come up like that. And then bounce. Come down here for the y-intercept, right? And then it turns at 7/3. And then it comes back up. Do you guys see that?
Yeah.
Okay. Are we all happy? Do you want to do one more graph? Do you want to do one more graph?
I'm fine. I don't know about the others. If they want, you can do one.
Maron, Naima, Shaida.
I understand now.
Okay. Okay, so let's do a question where we actually analyze the graphs. Okay. So see how easy it is. Once you've got an approach, you see, it's not easy, but once you have an approach, it's easy. And that's what maths is about. Maths is about developing approaches. And once you know the approach, it becomes so easy. Once you practice the approach and you become comfortable with the approach, it becomes enjoyable. Not just, that's when it becomes enjoyable. Okay, let's go to the next one. So what's the question now? Which one? Do you want to do that first one? Naima, do you want to do?
No, I
With
think no, something.
Do you want to do this one, Nafisa, with the
where they give you
sketch
the
along?
graph.
Yeah.
Yeah. Okay, we can do that.
Okay. Sketch alongside shows the graph. Okay, we can remove that now. Sketch alongside shows the graph of h of x equals ax cubed plus bx squared minus 12x. Do you notice how there's no constant term? Do you guys see that?
Yeah, that means there's no y value. It's zero.
No y value? What do you mean? No
Like the
y?
y is zero.
Say it again?
The y value is zero.
Don't say y value, because y value, there's lots of y values in this
The
graph.
y intercept.
Yeah,
Yeah.
sorry.
Yeah,
See.
so just be careful with the terminology. Okay, I know you meant that,
Yeah.
but just be careful with it, because in exam, if you write the y value is zero,
Yeah.
they're not gonna know that you mean what you mean. So okay, so then it says -1 and 7 and C are stationary points. Okay, and then P -9 is a point on H. Okay. So they're actually making it very nice for you. They're drawing a horizontal line showing you that's P -9. Okay. Show that A equals 2 and B equals -3. Now, we've done a lot of questions like this. And my approach to these questions always is to say, what is the information that they are giving me? And use that information to create equations. That's been my approach since matric, which was a long time ago. So what's the information they're giving me? They're telling me, they're giving me a y, they're giving me a y-intercept, right? But that's not really helpful. They're giving me a turning point, right? Turning point 1 -1 7, and they're giving me a point, right? Okay. But do you agree that -1 7 is also it's a point, not just a turning point? Do you guys agree?
Yes.
So that's why when they give you the turning point, they're actually giving you two pieces of information.
But why would you say that? Because it shows in the sketch that it is the turning point. So why would you say that it's also another point?
No, what I mean is there's two pieces of information, because this is firstly the turning point, so you can say the derivative is naught.
Yeah.
But the second piece of information is that you can actually sub -1 7 into the B equation.
Oh, okay. Yeah. Okay.
Do you see what I mean?
Yeah. Okay. I see.
So that's why it's two pieces of information. So so that's why turning point is so valuable, because it tells you two things. So let's create the two equations. So derivative equals naught. So what's the derivative of this graph? It's y equals ax cubed plus bx minus 12x. What's the derivative? What's the derivative, guys? You guys hear me?
Yes, we can.
Yeah, what's the derivative?
It's 3ax squared plus bx minus
Bx.
12.
Just B.
Just b
Oh, just
minus.
b. 12.
Mm. Do you notice that bx and 12x are actually like the same?
No, wait on
No,
the
wait, sorry, it's bx squared, sorry, it's bx
yeah.
squared. I wrote it correctly. That's my mistake, sorry. So it's 3x squared plus
BX.
2bx.
Oh, yes.
And then,
minus 12.
and we are saying that the derivative equals naught when, what are we saying?
At the tipping point.
Yeah, but in this equation, what are we saying?
Oh.
What does the equation want to know? So I'm putting this equal to naught, but the equation, like Ilya's like, you putting equal to naught, but like, you're not even telling me where it's equal to naught. What else can I fill in here that I already have? You want to solve for a and b, but don't you have x?
You have the x value. Yeah.
Do you guys agree?
Yes.
So that's why you must understand the equation. The equation is saying, where are my turning points? This is the English of this equation. Derivative equals naught. The English is where are my turning points? But you're like, hey, I already know my turning point is at -1,7, so I can sub it -1 for x. Do you guys see that?
Yeah.
So it becomes 3a times -1 squared, which is 1, minus 2b equals 12. That's the first equation. In the second equation, we get a sub -1,7 into the main one. So if we sub -1,7 into the main one, it becomes 7 equals
A negative A cubed.
but don't we have not a cubed, remember it's x cubed. So if a is x is -1, then it's just -1.
Yeah.
Plus b plus 12. So we could therefore say that, minus a plus b equals -5. If we take the 12 over. Okay. Guys agree?
Yeah.
Hello. Okay. And how can we solve this? What's a quick way to solve this?
Elimination. Oh no.
You can do elimination, but what do you need to do?
Add them.
You can, but what's the point of elimination? To eliminate. If you add them, are you eliminating? Do you see what I'm saying?
Yeah.
So what can you do to eliminate?
You subtract.
No.
Oh.
The only way to eliminate is if they're equal in some way. What
I
can
would
you
make
do?
b the subject of the formula and then sub it back in and work it out. as simultaneously.
Yeah, that is one way. But a slightly faster way would to multiply the second equation by 2. So then it becomes minus 2a plus 2b equals minus 10. Then you can add the equations. You see that?
Oh, yes.
Then the b's cancel. So I'm multiplying it so that I get them to be the same. So 3 minus 2a is
Yes,
a,
that's why.
and 12 minus 10. No, wait. No, 12 plus minus 10, yeah, is 2. And they said to us, they said a is 2. Yeah, a is 2. And then, did you see that, Nafisa?
Yes, I did.
So, I mean, both
It's
ways
quicker.
work. It's just a bit quicker, yeah. So, and then they say that, the first equation was that minus a plus b equals minus 5. So you can just sub it in to any of these, and then you get a, b equals minus 3, I think. What do they want? Yeah, b equals minus 3. Okay, so do you guys see, whenever they ask you this question, you look for the information they give you, and then create equations, and you solve simultaneously. That's the approach. Guys, see that?
Yeah.
Shaida, right? Yeah, okay.
Yeah.
Okay, so do you see maths is about approaches? What's your approach to this question? Okay, calculate the length of, so now we know the equation of the graph. Huh? So that's the nice thing, is that we know the equation of the graph. So we can say y equals 2x cubed plus b, which is minus 3. So it's minus 3x squared plus minus 12x. Okay, you guys happy? The length of AB. What's AB?
Our x-intercept.
So what can you do to work out AB?
You can just
Make
count,
y.
should I?
Oh,
All
They
that.
say round to 2 decimal places, so I have a feeling that it's not a nice calculation. So what can you do to work out the,
make y equal to 0, and then
make y equals 0, so it becomes 0 equals 2x cubed minus 3x squared minus 12x. Yeah, sure. Can you divide by x? Can't you divide by x? You see that?
yeah.
Okay. And then can we solve this? Can we factorize this? I don't think we can. Just say 2 minus
Yeah,
3.
it gives you some, but
Yeah, it's not. So the answers that we get are it's x plus it's 3,31, x equals 3,31, and minus 8, but you guys can just, you guys know the quadratic equation, right?
yeah.
So you can just use that. So what's the distance? It's about what? It's about 5.12.
But yeah.
And they wanted to 2 decimal places, right? And then it says the value of p. Where's P? Where's P? Where's P? Guys? Where's P on the graph?
P is the x-intercept of S.
So how could you work out P?
Do we substitute into the equation of the graph?
Yes. Because can't you, because you guys agree, if you sub in a
Yeah,
y
why?
value, it will tell you the x value, right? If you sub in a y value, it will tell you the x value. Just like if you sub in an x value, it will tell you the y value. Do you guys see that?
Yeah.
So she's saying sub in -9, then solve for x. Do you agree? Because if you sub in -9, it'll tell you the values of x that will give you a value of -9. Do you guys see that? Talk to me, guys.
Yes. Yes.
You can say no also. Okay, you can say no. I can explain it. Are we on the same page? Do you understand, Sherman? So she's saying sub 9 into that. So then it becomes 9 equals, or you could just, if you just want to be quick, then just say naught. Could you take the 9 over, right? So 2x cubed minus 3x squared minus 12x minus 9. If you take the 9 over, it's plus 9, sorry, plus 9.
Sorry, it's +9, yeah.
Yeah. And we can do synthetic division. So what's the factors? Are there any factors? Are there any 2 minus 3 is minus 1 minus 12? Let me just find out quickly. 2 minus 3 minus 12 minus 9. Yes, 3 is a 3 is a factor. Sorry, 3 is a root, so it's x minus 3. So sometimes you just have to sub in different values. So using the synthetic division, it becomes 3. What are the coefficients? It's what? 2. I want you guys to all try this. Okay. Guys, I'm going to give you 30 seconds to do it. Naima, you guys doing it?
Trying. So wait, the first thing I must multiply 3 times 2 or what? I don't know.
So you bring
I must
this
bring
down.
3 down.
So bring 2 down. Bring
Oh.
2 down.
Put 2 down. Okay, and then
You multiply by this by that.
okay, so that gives you 6. Then you 8, right?
Yeah. So what's, yeah?
You get 3. Then you say 3 times 6. So that will give you.
No, 3 times
Yeah.
this.
Oh, yeah.
What
Okay,
you put
so
here, you add to that, and then you multiply by that.
Oh, okay.
minus 12 plus 9.
minus 3.
3 times minus 3.
Minus 9.
Great. So what's your final, what are your brackets?
Oh, this is actually easy.
See, I told you. So the brackets
Not
are,
fair.
Yeah.
okay, so the brackets are
minus
x minus 3, and then the other bracket is 2x squared minus 3x minus 3.
And you can't factorize this one. But anyway, so do you guys notice there are 3 answers, 3 roots? And why does it make sense that there are 3 roots?
Because there are 3 x-intercepts.
Yeah, but in the context of this graph, what is the question asking you? It's asking you to find P, right? And what did you do to find P?
You made y equal to negative 9.
So what's the equation going to tell you if you make y equal minus 9?
What's the x value when y is negative 9?
And how many x values on that graph have a y value of minus 9?
2, because it's the straight line is showing you this.
So
No,
continue the straight
yes.
line. Continue the straight line to the left.
Oh, yes, there's 3.
There are 3 points where the graph equals minus 9, the y value. Do you see that?
Yeah.
So do you see why you got 3 answers?
Yeah.
Because the equation is not as smart as you, man. So like the equation doesn't know, like, you know, which one, like, they're telling me to find like where y is minus 9. So I'm just gonna give them all because I don't know which one they want. So I'm just gonna give them all. So they gave you this one, they gave you that one, and they gave you that one. Do you see that?
Yeah.
At all those places, y was minus 9. So how are you going to work out which one is P? You take the biggest one.
Yeah, so it will be 3, isn't
It's going to be 3.
it?
Yeah. Good. Do you guys see that?
Yeah.
Did you see? Do you understand why these equations? Because like a lot of people will just put it into the equation and then get an answer, and they're like, okay, flip, what do I do now? Like, but what you must realize that you're getting this 3 answers because you're asking the equation to tell you, listen here, where on the graph is y equal minus 9? That's what you're asking the equation. You say, listen, you please just tell me where's the graph equaling minus 9 on, it's okay, I'll find out for you. And then it says, okay, well, there are 3 places. But even though you only want one, it doesn't know which one you want. So it's going to give you all 3. Do you see that?
Yeah.
Okay. Next question. Determine the equation of the tangent to H at S. Where's S? Okay, yeah. Here's S. So this is 3 minus 9. So Amaro, I want you to, okay, she's not here. What can you guys tell me about the tangent and, calculus, or what can you tell me?
The tangent at S will be positive or negative.
Yes, good. So if you draw the tangent, it's positive. So if you draw the tangent like that, right? That's the tangent. It's positive gradient, sure. What else can you tell me, Nafisa?
The Gradient is something about the something at that point. I forgot
Now,
what
I
that
want that to
something
be
is.
embedded. That must be embedded in your brain. Like you must sleep with that. Sleep with it. It's like when you wake up, that's the first thing you say. You must
Imagine waking up thinking about maths. No.
I used to do that.
No,
I
no,
used
no.
I used to wake up and then my phone would give me a maths question to solve. That's how it would wake me up. Okay. But like, what did you say now? You said you were nearly there. What's that rule about the tangent and the gradient? Nafisa, do you have any idea?
I forgot something about the x-intercept. I don't know.
Now I want you to memorize this. Put it into your brains. The gradient of the tangent
Is equal.
is equal to the gradient. Take a picture of this, print it out on your walls of the graph at the point
Point
of
of contact.
contact. So what does that mean? What that means is that if the gradient of the tangent is 3, then where it touches the graph's gradient must also be 3. Okay?
Yeah.
Let's actually just do this now. Send it to the grade 12 group. Stick picture. Please memorize. No, not that one. Students, please memorize this. Okay. Oh no, don't do that. Okay. Okay, so do you guys understand the statement? So if the gradient of the tangent is 5, that means the gradient of the graph here is 5.
Yeah.
Okay. So they're asking you to calculate the equation of the tangent. So whenever I see this statement equation, I think to myself, okay, Ilya's equation of tangent, it's going to be y minus y1 equals mx minus x1. Okay, that's the equation of the tangent. What do I have already?
The code.
You have the gradient.
Do you have the gradient right there? Or what do you have? What are the two aspects of this equation that you need to find? You need the gradient and
A set of coordinates.
do you have a set of coordinates?
Yes.
Yes, so that's what you have, right? So it's y plus 9 equals m x minus or x minus 3, right? Okay. So now you just need to find the gradient. So how are we going to find the gradient of the graph? Or the gradient of the tangent. They want the gradient of the tangent, sorry. Using this statement. They want you to find the gradient of the tangent. So how can you find it? Nafisa, any ideas?
Not really. Is this the same as working out average gradient? Or is it different?
What is the question asking you?
To work
What is
out the gradient of the tangent.
Yes.
So
And what do you know about the gradient of the tangent?
it's a straight line.
Yes, but this statement here,
It's equal
We
to the
know
graph gradient at the point of contact.
so can't you work out the gradient of the graph there? And then that must be the gradient of the tangent.
But isn't the gradient of the graph won't be equal like everywhere? It won't be the same everywhere.
Yes, that's why you have calculus, because calculus is there to tell you the gradient at a point, isn't it?
Yes.
For example, let's make up a gradient, derivative equals x squared plus 4. Is this derivative constant?
No.
No. So how do I work out the gradient? I can say, okay, I want to work out the gradient at x equals 4. So I sub in 4. Then therefore the gradient is 20. Do you see? It's the gradient at one point.
Oh, okay. So do we take 3 and substitute it in our derivative formula? Because then
Yes, exactly. Because won't that tell you the gradient, the derivative at 3,
yes,
which happens to be the gradient of the tangent
yes.
based on this statement? Nafisa,
yes. Yes.
does it make sense?
Yep.
Naima,
So
can
we
you explain it to me
just
again?
Hmm.
Yeah. Just try.
Okay, so our x value at s is 3, so we're gonna take it and put it in our gradient formula, and we'll get the gradient when the x value is 3, and that's the same as the gradient of our tangent.
Here we go. Based on this statement, right? The gradient of the tangent is the same as the gradient of the graph at the point at which they connect. So sometimes, guys, they might give you the gradient of the tangent and ask you what's the gradient of the graph. Do you see?
Yeah.
So then you could say, okay, if this gradient is 5, then I can sub in 5 for the gradient and solve for x. Where, and that will tell me where the gradient is 5. Now I know where the point is. I want to know the gradient. You see that? Naima?
Oh yeah, I do.
Okay. Remember, when I ask a question, it's for everyone. It's not a particular person, so you can just say yes. And
Okay.
okay. Point of inflection. What's the equation for point of inflection?
you work out second derivative.
Yes. And what do you do with the second derivative?
Oh, make it equal to 0.
Yeah. So that's why, like, you mustn't just say second derivative because second derivative is not, it's when the second derivative equals 0. So and when I ask people, Where's the turning point? Don't say when the first derivative. When the first derivative equals 0. Okay. So that must become ingrained when you wake up in the morning. Say first derivative equals 0. Turning point. Second derivative equals 0. Point inflection. Because the gradient of the tangent is the same as the gradient of the graph at the point of contact. Those are the 3 things when you wake up. You're gonna say after Salah. Those are the 3 things you're gonna say. Okay. So what's the second derivative? What's the derivative? 6x squared minus 6x minus 12. Therefore, the second derivative is
12. Yeah.
And therefore x equals
0.
uh
Oh, no, sorry. I was talking about. It would equal to 6 over negative 12. Not sure though.
no, 6 over 12, which is off.
Oh, yes.
And that kind of looks like off, right? If this is 3, then it looks like actually over here, right? It kind of looks like it's because remember we said point of inflection is when the concavity changes. So here it's above the graph, above the graph, above the graph, above the graph. Then what happens here? Do you see what happens here? It goes below the graph. Okay. It is further given that C is 2 minus 20. Okay, let's just erase that now. C is C is 2 minus 20. Okay. Determine the values of t for which h of x equals t has 3, 2, 1. Okay, this is, it looks complicated, but it's such an easy question. And I'm going to show you what I do, okay? Firstly, what does h of x equal t mean? If you think of t as a graph, y equals t, and you say where h of x equals t, what does that mean? Guys? If you make y equals t a graph, and you say h of x equals t, and there are lots of questions like this on the bank that I want you guys to try out. Okay, so
it means that our graphs are equal. I don't know.
Yes. If this was a graph, y equals t is a graph, and you say h of x was equal to, you're basically saying, Ilias, tell me where does the cubic function intersect with t? Do you guys agree?
Yeah.
Nafisa?
Yes.
Shaida?
Yes.
Okay. Now my next question to you is, what is the graph of y equals t? What type of graph?
Straight line.
Yes, but I want something more.
Horizontal line.
Yes. Why is it horizontal line?
Because it's just a y equals something. So when it's y equals something, it's a horizontal line.
Whenever y equals a constant, that's also something you must memorize in the morning. Y equals a constant is a horizontal line. And when x equals a constant, it's a
vertical line.
Vertical line. So y equals t is a straight line, just like that. No, wait, don't do that. Straight, just like this. It's just a horizontal line, like that. And remember we said they want to know where the graph of h of x equals t. In other words, where does h of x, when h of x equals t, it's when the cubic graph intersects with the graph y equals t, right? Do you guys see that? Does everybody see that?
Yes.
Yes.
Do you agree I can choose t to be any number? T could be naught over here, right? On the x-axis. T could be 5. T could be -2. T could be -10. T could be -50. T could be -100. Do you guys see that?
Yes.
All I'm doing is the value of t just tells me how much I'm shifting this graph up and down. Do you see that? Nafisa?
Yes. Yes.
Naima? So what is
Yes,
my
we see.
question? What's the question asking me? Read the question to me. Who wants to read? Shaida, can you read the question for me?
Determine the
Shaida.
values of t for which h of x equals to t.
Has
Has 3 distinct real roots.
and what did we say a root is? It's just where it's the solution to the equation. But this equation is h of x equals t. Isn't h of x equals t where the graphs intersect?
Yes.
How many
So,
roots when t is naught? How many
Huh?
intersections?
I didn't get the question.
Okay. What is the question asking? The question is saying, determine the values of t for which h of x equals t. Now, what is h of x? H of x is the cubic graph, right? H of x is the
Yes.
cubic graph. And t is just a horizontal line.
Right.
They're asking the values of t such that the graph will have 3 intersections with the two graphs, 2 intersections and 1 intersection. Do you see that? Because
Yeah.
what do we mean by root? What does root mean?
The intercepts, the x-intercepts.
Yeah, but it's almost like it's the solution to the equation. What's the solution to this equation? You're putting two graphs equal to each other. What's the solution? Going to tell you. When you put two graphs equal to each other.
The intersecting point.
Yes. So in other words, when they say root, they mean intersection. That's what they imply. So in other words, for which value of t will this graph have 3 intersections, 2 intersections, or 1 intersection? Do you guys see that?
Yes.
Yeah.
When t is naught, how many intersections?
3. No.
Yes, 3.
3.
1, 2, 3.
Mm-hmm.
And here, when t is 7, remember
Just
t is a
one.
y value. Just 2, 2,
Oh, right.
2. And then here, how many?
None.
No.
Oh, 1 because it will extend, isn't? Yeah.
Okay. So 1. Is everybody following?
Yes.
No, that wasn't happening. Okay. T is what? If t is above 7, there's 1 intersection. If t is at 7, there's 2. If t is below 7, how many?
3.
3. And when t is minus 20?
2.
Right. And when t is minus 25?
1.
Do you guys see how we're answering this question? We know there are 3 distinct roots when t is between minus 20 and 7. When is when is there two distinct roots? When t is minus 20 and t is equal to 7. When is there one root? When t is above 7 and below minus 20. Does that make sense? Talk to me, talk to me.
Yes, it does.
does. Mhm.
So can you answer all the questions like this now?
Yes, hopefully.
One of you want to try and explain the question to me?
Which question?
This question. Number 6. I just want to see if you understand.
Okay, so for the 3 distinct roots, it will be the x-intercept will be in between the turning points, so 7 and negative 20. Right.
Yeah. Don't say x-intercept. Rather just say root. Yeah, root. Yeah.
The root.
Yeah.
Okay.
But Nafisa, what do you mean by horizontal? What's intersecting? Nafisa?
Yes. I don't know. The roots basically.
Graph and the straight line.
So what's h of x equals t? What does that mean?
The two graphs are equal. And the
intersecting points.
So what are the two graphs that you have?
The cubic graph and the straight line, the horizontal.
Why is it horizontal line? How do you know it's horizontal line?
Because we said y is equal to t.
And what is t?
A straight line.
T is a constant. And whenever y equals a constant,
it's a horizontal line.
Yes. Yes. Okay, good. So they're asking you, when the cubic graph intersects with this horizontal line, what is the value of the t, which is just the horizontal, that's the vertical shift of that horizontal line, right? Do you agree horizontal graph cannot shift to the left or to the right?
Yeah, it can only move up and down.
It can only move up and down. So therefore the t represents the vertical shift.
Mm-hmm.
Just like every constant, right? Doesn't every constant in a graph represent a vertical shift? Do you guys agree? Just like in the straight line graph, isn't that a vertical shift? In the parabola, isn't the constant a vertical shift?
Yep.
So therefore, if your graph is only a constant, what does that mean? It can only.
It's just a straight line that moves up or down.
Exactly. But now they're asking you, when those two graphs intersect, where they're intersecting 3 times, because the graphs are equal 3 times, over here, and over here they're 2 times, and here 1 time. Do you guys all see that?
Yes.
Yeah.
Okay, so you see how what they're giving you here is maths, but you have to translate that into English. And once you master that, like your whole experience of maths just becomes so much more like enjoyable. Because maths is a language, right? If you can't translate, then you're gonna struggle. Because maths is not gibberish. They're actually trying to communicate something to you. And that's why you have to study the language, terminology. When they use the word stationary point, automatically you must translate that into derivative equals naught. When they use the word tangent, automatically think, okay, the gradient of the tangent is the same as the gradient of the graph at the point of contact. this is English, but we want to translate that into maths. Okay. This is maths, but now we translate into English. Okay. Do you want to do the second question?
Yeah, sure.
Okay. I think that will be the last one. Okay.
Isn't it just equal to 7 and negative 20?
Where's this?
The second one.
Oh no, I mean this one. D. I
Huh?
thought we answered this already.
Oh. Oh.
Yeah.
Oh. I kind of have to go. Can I leave?
Yeah, I mean,
Mhm.
I can't. Yeah, I mean, you guys can
Okay.
come and go.
And
I can't.
then I will watch the D.
It is
in the
recorded. It is
recording.
recorded.
Yeah.
It is recorded, and it's on. It's actually live recorded, so you can actually go straight onto YouTube now.
I can see on top it says live on YouTube.
Yeah, that saves time. Yeah, so we actually
Okay,
all
so
live. All those who are watching. Yeah, there's actually one person watching, which is me. Anyway, okay, I'll see you guys. See you next episode.
okay, shukran for the lesson, Salam.
Okay, so the graph of x cubed plus mx squared, okay, x cubed plus mx squared plus nx, right? Okay, y equals. So there's two things we don't know, m and n, right? M and n. Okay, m and n. Yeah, you could predict. So what are we gonna do here? What did we say, Naima? How can we? What's the approach to these types of questions?
The derivative isn't.
When they want you to find those parts of the equation, what's the approach? You look for two pieces of information, right? Two unknowns,
Yes,
two pieces of information.
they give
So
you.
what are the two pieces of information?
They gave us P,
So
and
that's
they
the
told
point,
us
right?
yeah.
Yes, and
Mm,
you need a
they
second
gave
piece of
us
information.
the graph. I mean the equation.
Yeah. No, but you need another piece of information because the equation is what you're going to. You need to do something to the equation.
The
What's the second?
derivative.
No, they don't say anything about the first derivative. What else did they say? They say the point. You've got a point, right? And what's next to that?
The point of inflection.
Yes. And what do we know about the points of inflection? So I know you haven't done calculus, but it's where the second derivative is naught.
Yes.
So you see, those are the two pieces of information. Now you've got a point and you've got the second derivative equals naught. Do you see that?
Yeah.
So you can sub in the point, so it becomes -7 equals -1 because it's x cubed plus m minus n. So m minus n equals -6. Okay, I'm just subbing these points in, right, into this equation. Then I can use the second derivative, which is, so the first derivative is 3x squared plus 2mx plus n, and the second derivative is going to be 6x plus 2m.
Yeah.
Equals 0, right? But
Yes.
what are they telling us about the point of inflection? What did they say? Where's the point of inflection?
They're telling us about the point P.
Yes. So can't you sub in the x value? Can't you sub in the x value of p into here? And then solve for m?
Yeah.
So what's the x? It's -1. So it's -6 plus 2m equals 0. Therefore, 2m equals 6, and therefore m equals 3. And if m is 3, then you'll get n to be 9. Okay, but you know how to sub back in. Okay. But do you see how the
Okay, so
approach is?
whenever they give us this question, you first look for the point, any point they give you, and the derivative.
You look at they want two pieces, they want two answers, so there's two unknowns. So you ask yourself, what are
Right.
I need two pieces of information. It may not be the derivative, but
Okay,
you have a
any two.
point, any 2 points. Because remember, isn't this this is English, right?
Yes.
This is English, but there's a mathematical equivalent of this, which is to the second derivative equals 0.
Yeah. Okay.
There's a mathematical equivalent of this, which is when you sub that into the equation. You see, so everything that they tell you in English can be translated into maths. And that's the point that I'm trying to get across to you. Because when you read it, it's English, but it's actually also maths. And you have to translate. Okay.
Yep.
So the equation of the graph, so what's the equation going to be of the cubic graph?
X cubed plus 3x squared plus 9x.
Yeah. X squared, 3x squared plus, sorry, x cubed plus 3x squared. I'm not writing this properly. Yeah?
It's okay.
I'm looking above and then writing x cubed plus 3x squared plus 9x, right?
Yeah.
And then they're asking us, show that it has no stationary points. And how do we find the stationary points?
Find the derivative and make it equal to 0.
Which is 3x squared plus 6x plus 9 equals 0. What can you do?
Trinomial.
Yeah, but I would divide out by the 3. So it becomes x squared plus 3x plus 3. 2x plus 3.
Yeah.
Okay. Now they are asking you to show that there's no stationary points.
So that means that you won't get any, like it won't give you any point.
Exactly. So what can we say about the roots? If there's
Non-real.
yes, non-real.
Non-real.
How can you prove that they're non-real?
You
What's
use
the-
nature of
Yes,
delta.
and what do you say?
So
What's
delta is
delta is what?
equal to
Not equal to.
you use the
Want delta to be non-real. Shaida, do you have any idea?
Delta is less than 0.
Yes, delta is less than 0. Naima?
yes.
For the roots to be non-real, delta must be less than 0.
Right.
So find delta. What's delta equal to? Shaida?
It's b squared minus 4ac.
So what's b squared minus 4ac? What's
2
b?
squared minus 4 into 1 times 3. So that will give you -8.
So what does that mean?
So
Delta equals
up
-8.
yeah,
Therefore,
up until -8 there's no stationary point. Does it mean
no,
that? I don't know.
no, it means, no, delta is less than 0. So, okay, I want you to watch the concept video, Naima, it's on the sections mind map, okay?
Yeah.
On the section
Okay.
on algebra. But basically delta being negative means that there are no real roots. The roots are non-real. So if we were to draw a graph, it would be like this. Remember we said the roots are like the x-intercepts?
Yeah.
Yeah.
What do you notice about this graph?
No x-intercept.
Right. Which means the graph never touches 0. The graph is never equal to 0.
Oh, okay. Then what does delta equal to -8 mean?
So that's how you prove this. So
Oh.
so this is equal to that. When delta is less than 0, it means that the graph does not touch the x-axis. So you could have another graph like this. Right?
Right.
Doesn't touch the x-axis. So you've got a parabola, right?
Mm-hmm.
And they're asking you to show that there are no stationary points. But you know the stationary points is when this is equal to 0. The derivative. So so you can just find delta and show that delta is less than 0. Therefore, this can never equal 0.
Oh,
And since
right.
this can never equal 0, the derivative can never equal 0. And if the derivative can never equal 0, then there are
There's
no
no
stationary
stationary
points.
point.
You
Okay,
see
I
how
get it.
it's very logical. Okay. Now it says the equation of the tangent at P. The equation of the tangent at P. Okay. Do you want to try this one, Shaida? Shaida? So how can you break down this equation? I mean, break down this question for me.
The gradient at P
Mm.
to that the graph at that point.
Right, the gradient of the tangent at P. Let's change the color. The gradient of the tangent at P is the same as the gradient of the graph at P. Do you agree?
Yeah.
What's the gradient of the graph at P? Can you work it out?
Yeah, we can.
How?
You
You
take
find
the x value and sub it into the derivative formula.
great.
You
Okay, 100%. Okay, so it's 3x squared plus we said m was 3, so it's 6x plus 9. So if you sub in -1, it becomes 3 minus 6, which is -3, plus 9, which is 6.
yes.
And you've got
Yeah,
a point, right?
it is.
So because you've got a point and you've got a gradient, you can work out the equation. Okay. Do you agree?
Yes.
Now the last one is interesting. It says the equations of the two tangents are to F parallel to the line y equals y minus f. Let's just write down the information. Always write them. They're mentioning tangents. So then you have to think to yourself, what are all the properties of tangents? They're giving me a line y, so write that y equals 9x plus 10, right?
Mm-hmm.
And they're saying that is parallel to f. What does parallel mean?
The gradients are the same.
Do you see how that's maths? This is English, right? That's
Yeah.
English. But the maths, the gradients are the same. Do you see how we can translate stuff now?
Yeah.
So they're essentially asking you, what are the equations of the tangents which have the same gradient? Or where on the graph is the gradient 9? Determine the equations of the tangents which are parallel to this graph. Parallel means the gradients are the same. So essentially they're asking you, find the equations of the tangents which have the same gradient as this graph. What's the gradient of this graph?
It's 9.
It's 9.
9.
So what's the question asking you essentially?
Which other tangents have the same gradient?
Yes, but remember, this
So
is
how
not
do
a
we do
tangent.
that?
This is not a tangent, right? This is just a line.
Yeah.
But they want to know what is the equation of the tangents which have the same, which are parallel to this line. Parallel to this line. Do you agree?
Yeah.
They're parallel to this line. But what does that mean? It means that the gradients are the same. That's the link. That's the maths. So if you want to work out the equation of a line, right, you need two things. You need a gradient and you need a point.
We have the gradient, but we don't have the point. What we do?
If you have the derivative and you sub in the gradient, can't you solve for the point?
Oh, right.
Do you see that?
Yeah.
Do you understand the question?
Yes.
So do you see how we broke down the question? The question is saying, find the equations of the tangents which have the same gradient as this line y equals 9x plus 10. In other words, find the tangents on the graph which have a gradient of 9, which also just means find the place on the graph where the gradient is 9. Do we understand each other?
Yeah. So now we solve this.
It's a difficult question, but I just want you to understand how even the most difficult questions, you can break them down. You know, that we're just breaking them down. There's no new maths. It's the same maths, but they're just combining things. Okay?
Yeah.
So yeah, so you could work out the equations, the tangents, because you know the points, right? So the equation of the tangent is just y minus y1 equals mx minus x1, right? And you know the gradient is 9.
Yeah.
So all you have to do is work out the points. Where is the gradient 9? Well, can't you sub 9 into the derivative formula and then find the corresponding x value?
Yeah. So we can take the 9. Oh, no.
Yes, you can. Say it.
Yeah, so you take the 9 over and then you solve for x. You'll have to also pull out a common factor because It won't be a
3x
trinomial.
x plus 2 equals 0.
Yeah.
Because the 9's cancel. So therefore
Yes.
x equals
0
0
and -2.
But look at this
Now
graph.
we need to,
Look where x is 0.
yeah.
Where is x 0? Look at this graph here. Where is x 0?
Yeah, in the center.
The origin. So what's the y value?
0.
So you don't have to do that. You don't have to find.
Yeah.
So therefore the one tangent is just y equals 9x. There's no constant because the y-intercept is 0. The other one, we say y minus, okay, we have to sub this into the equation, right? So it's x cubed plus 3x squared plus 9x, right? So you sub in -2. So it's -8 plus 12, which is 4. -18 is -14. I think, am I correct? Okay. So then you sub this in here. So it becomes y plus 14 equals 9x minus x plus 2. Therefore, y equals 9x. 9 times 2 is 18 minus 14 is -4. Should make sense.
Yes.
Yeah. It's a difficult question, but I just want you to understand the concept, even if it means watching this part back again on YouTube, right? So you can watch it again. Okay. We're all a bit over our time,
Yeah.
but
Yeah.
yeah, do you have any last questions?
No.
Our next class is on Thursday,
No.
so you can come with more questions if you have. Okay. Okay. See you guys.
Okay.
Bye.
Okay.
Okay.